Welcome back to the deep dive. Now, if you're a DOP, maybe a high-end editor, someone really invested in image quality production workflows, well, you're stepping into something new with visionOS immersive content.
It absolutely is a new frontier.
Yeah.
And what we want to do today is really cut through some of the noise. We're not just listing specs. We're trying to pull out the crucial stuff you need to know now.
Yeah, the practical knowledge.
Exactly. The formats, the pipelines, some creative basics. Basically, how to get started on high-end immersive stuff without getting completely swamped.
Because the device itself, the Vision Pro,
Okay.
it's being called the ultimate storytelling device, isn't it?
And for good reason. You've got these incredible displays, 23 million pixels total, plus high-fidelity spatial audio.
That combination just gives you the sense of presence, of depth that we haven't really seen before. Stories feel sharper, more real.
But yeah, that level of realism, it demands a different way of thinking about capture, about post, about everything, really.
So where do we start? The formats, maybe?
Let's start there. The meaty format spectrum.
Yeah.
visionOS supports, your standard 2D video, no surprise there.
Right.
But for the spatial stuff, we need to distinguish between traditional stereoscopic 3D and these newer spatial formats.
Okay, so standard 2D works fine. What about traditional 3D movies?
Yep, they play stereoscopically. You get that depth, usually in an expanded view, filling the app window.
Ah, but there's a catch for designers, right?
Yeah.
If you embed that 3D video inline next to UI elements.
Good point. Yeah, it has to gracefully fall back to 2D in that context. You lose the stereo effect inline to maintain the UI layout, to practical limitation.
Makes sense.
But then you have spatial video. And what's interesting here is how Apple's tried to make comfortable stereo capture much, much easier.
Easier how? You don't need to be a stereographer with decades of experience.
Pretty much. It's designed so you don't have to manually wrestle with, convergence points and interocular distances and all those complex 3D rules. It aims for comfortable stereo out of the box.
And you can shoot it on, newer iPhones, obviously.
iPhone's the Vision Pro itself. And now we're seeing dedicated options like the Canon R7 or R50 with that specific Canon dual lens attachment.
Okay. And how does it look when you play it back?
It starts in this sort of portal-like window, but then the viewer can expand it. And that's when the edges kind of dissolve and the video blends more into your actual environment. It feels quite immersive.
And crucially for our audience, the post-production side. Is it supported?
Oh, yeah, that's key. Spatial video format is supported in the main tools.
Yeah.
Compressor, DaVinci Resolve Studio, Final Cut Pro on the Mac. You can bring those clips right into your professional workflow.
So you treat it like another asset, just with depth.
Exactly. It integrates pretty seamlessly.
Okay, so that's spatial video, but then we get into the really wide stuff, the big immersive projections. You mentioned APMP.
Right, APMP. Apple Projected Media Profile. This came with visionOS 2.6. It's a new profile for QuickTime movies that lets you handle non-rectilinear, basically curved projections.
Curved projections?
Well, three main types right now. First, 180-degree video. Think of it projected onto a half sphere right in front of you. It fills your forward view completely.
Feels like you're there.
That's the idea. It uses what's called a half equirectangular projection, or half.
Then there's the full sphere.
Yep. Classic 360 video uses the standard equirectangular projection to wrap the image all around you.
Okay, standard enough. But you mentioned something for action cams. That sounds interesting.
Yeah, the wide field of view type. This is designed specifically for things like GoPros, the Insta360 Ace Pro cameras, with those super wide, often fisheye style lenses.
Which usually look pretty distorted, right? Straight lines curve like crazy.
Exactly. So this format uses something called parametric immersive projection. The system knows the specific profile of that wide-angle lens.
Ah, okay.
And it uses that information to project the image onto a curved surface that essentially counteracts the lens distortion for the viewer.
So straight lines in the scene actually look straight when you're watching it, even at the edges.
That's the goal. It undoes the fisheye effect dynamically, preserving the geometry. It's pretty clever for getting usable footage from those wide action shots.
That's a huge step up for action content. But all this stereo, high-res stuff, the file sizes must be astronomical. How do we actually deliver this efficiently?
Right. Critical point for anyone distributing this content. The absolute key is MV-HEVC.
Multi-view HEVC.
Okay, MV-HEVC for all stereo formats, spatial video, AIV, everything.
Yes. You really need to use it for anything stereoscopic going onto the platform.
How does it work? Is it just compressing both eyes separately?
No, that's the clever bit. It encodes the two eye views together. It fully encodes one eye, but for the second eye, it mainly just encodes the differences, the parallax information relative to the first.
Ah, because the two views are mostly similar, just slightly shifted.
Precisely. And those differences are much smaller data-wise than a whole second frame. So the result is a significantly smaller file size compared to just packing two full streams side by side. And the quality holds up. You don't perceive a loss in the second eye view because of that difference-based compression.
For the viewer, the perceived quality difference is negligible because the views are so close geometrically. The efficiency gain, though, is massive. It's really what makes streaming high-res stereo feasible.
Gotcha. Okay, so MVHEVC is non-negotiable for delivery. That covers the more accessible end. What about the really high end, the cinematic stuff?
Right, now we're talking Apple Immersive Video, or AIV. This is the format built from the ground up for top-tier quality, advanced workflows, the whole 9 yards.
And the capture side of that, there's a dedicated camera now.
There is. The first one out of the gate is the Blackmagic design Ursa Immersive.
And the specs on that thing are, well, they're pretty wild.
They are. It captures stereo video at 8160 by 7200 pixels per eye.
Per eye. Wait, so that's over 118 megapixels per frame.
Yep, and it does that at 90 frames per second.
Wow.
Plus, a really wide field of view up to 210 degrees horizontal. It's
Right.
capturing an immense amount of information.
Okay, that much data handling must be critical. You mentioned calibration.
Absolutely crucial. Each camera, specifically each lens and sensor pair, is individually calibrated at the factory.
Okay.
And that calibration data is stored in a special file called an ILPD, an Immersive Lens Profile data file.
And that file, it has to stay with the footage.
It must follow the footage through the entire post-production pipeline. Editing, VFX, color, everything.
What happens if, say, an assistant editor misplaces that ILPD file? Is the footage just toast? Or can you try and fix it?
For the high-fidelity playback on Vision Pro, it's essentially unusable without it. The system relies on that specific ILPD data at runtime to correctly undistort and map the image based on that exact camera's geometry.
Right.
Without it, the depth is wrong, the geometry is wrong, the whole immersive effect breaks down. It's a core part of the AIV integrity.
So the workflow has to be locked down, capture on the Blackmagic. Then where does post happen?
All the main post tasks editing, any VFX work, the spatial audio mix, color grading, that's all consolidated currently within DaVinci Resolve Studio on the Mac.
Okay, Resolve handles the heavy lifting. How do you check your work? See how it looks in the headset?
There's the Apple Immersive Video Utility app. It runs on macOS and visionOS. Lets you preview and validate the content in the targeted environment before you finalize.
And then delivery. Packaging it for streaming.
That's handled by Apple's Compressor app. An upcoming version will support the necessary content segmentation for streaming AIV using HLS.
Right, and audio. You mentioned spatial audio. It uses AF.
Correct. The Apple Spatial Audio format. That defines the 3D positioning of sounds.
And there's specific codec, too. APAC.
Yeah, APAC, the Apple Positional Audio Codec. Think of ASAF as the what and where of the sound, and APAC as the how it gets efficiently compressed and streamed.
So APAC optimizes the delivery of that complex spatial mix.
Exactly. It's designed for high efficiency with positional audio data. You mix using Fairlight within Resolve, or you can use the ASF Production Suite, which is a free AAX plugin for Pro Tools. APAC ensures that mix gets to the listener accurately.
Okay, within the AIV post, there are a couple of unique technical things editors need to get their heads around. First, dynamic edge blends. What's that about?
This is about making the boundary between the AIV content and the real world seamless. It's not like a hard mask or a baked-in vignette.
Right.
Instead, you define a custom curve, a shot if needed, that dynamically feathers the edges of the video during playback. It lets the immersive content blend smoothly into the user's surroundings.
Making the screen disappear, essentially.
That's the goal.
And the other big one, static foveation. This sounds like a compression trick, but how does it impact the creative side for the DOP or editor?
It is definitely an efficiency technique. Given the massive 8K per eye resolution, streaming that raw is just not feasible. Static foveation dedicates more pixels, more of the encoded data budget, to the center of the frame where the viewer is most likely looking.
So the center is super sharp and the periphery less so.
Perceptually, yes. It prioritizes the area of primary importance. The implication for composition is huge.
How so?
As a DOP or editor, you have to be very aware that the highest visual fidelity is locked to the center of the lens's view. if you place critical action or a crucial detail too far off towards the edge.
It might not look as sharp.
Exactly. It might suffer a perceptual drop in quality compared to something dead center. It sort of forces you to compose towards the middle, which is a constraint, but it's necessary for managing the data rates.
Okay, that makes sense. We've got the formats, the high-end AIV pipeline. Let's shift gears now to maybe the most critical part for the viewer experience: comfort and creativity. This feels like a huge mindset shift from traditional filmmaking.
It really is. Principle number one has to be presence and composition. The hardest habit for experienced DOPs to break is relying on the rectangle.
You mean like rule of thirds, leading lines, framing within the frame?
All of that. In these truly immersive formats, especially 180 or AIV, the frame effectively disappears. The camera is the audience. You're asking them to inhabit that viewpoint.
So composition becomes about depth.
Parallax.
Absolutely. You compose using depth cues, how objects relate in 3D space, and crucially, keep the horizon level, keep the camera height natural, usually aligned with the subject's eye line.
Because if the horizon's tilted or the camera's weirdly low or high,
it instantly breaks the feeling of being there. It feels artificial, simulated, and can even contribute to discomfort. Level horizon, natural height, foundational for presence.
Okay. Principle two.
Authenticity and audience agency. This is huge. Because the viewer can literally look anywhere within the scene, any attempt at filmmaker artifice becomes incredibly obvious and jarring.
What kind of artifice? Like bad Foley sounds? That, or maybe a really dramatic, unmotivated zoom. Or super fast cuts trying to hide something. In this high-fidelity view, tiny details matter. Subtle body language, micro-expressions, they're all visible. If something feels fake, it shatters the illusion.
And the agency part, you can't force the viewer to look somewhere.
You shouldn't try to force them with jarring camera moves. Instead, you preserve their agency. You guide their attention.
No.
The best tool is spatial audio. Use sound cues, a voice off-screen, a distinct sound effect placed accurately in 3D space to draw the viewer's attention naturally towards a story point or a reveal.
So they feel like they discovered it themselves.
Exactly. It's far more effective and comfortable than yanking their head around with a fast pan.
Right. Okay. Principle 3.
Proximity. And this requires totally rethinking the close-up.
No more zooming in for intimacy.
Nope. Immersive close-ups are achieved by physically moving the camera closer to the subject, which immediately brings up the concept of personal space.
The 4 P's of space.
Public, professional, private, and personal. And that personal space zone is critical here. There's a pretty hard rule of thumb.
Which is?
Placing the camera lens closer than about an arm's reach, say, less than 3 feet or roughly 1 meter from your subject, puts that subject inside the audience's perceived personal space.
And that feels uncomfortable.
Extremely uncomfortable for most viewers. Think about someone suddenly getting right in your face in real life. It's invasive. In immersive video, it's worse.
Way worse.
Because it not only feels socially awkward, but it also often causes technical problems like excessive parallax that the eyes struggle to resolve. It breaks immersion, creates discomfort, pulls the viewer right out of the story.
So those super tight, intimate shots need to be used very, very carefully.
Sparingly, and with strong creative justification. Violating that personal space bubble without a clear narrative reason is probably one of the quickest ways to ruin an immersive scene.
Good to know. Okay, final principle.
Connection and motion comfort. This is maybe the biggest battleground for editors and DOPs coming from traditional cinema.
Because camera movement feels completely different.
Completely. The viewer feels like they're the ones moving. Any camera motion directly translates to a sensation of self-motion for the audience.
Which can lead to motion sickness, right? The visual vestibular conflict.
Exactly. Motion discomfort. So in production, the advice is always have a clear creative motivation for movement. Don't just move the camera, because you can. And crucially, minimize the number of simultaneous movement axes.
Like do a dolly push or a jib up or a pan, but not all 3 at once.
Precisely. Combining multiple complex movements is a recipe for discomfort. And also remember, speed is relative to proximity.
How do you mean?
A relatively slow camera move that's skimming just inches above the ground can actually feel more intense and uncomfortable than a much faster move shot from, say, a drone high up in the air. Proximity amplifies the sensation of speed.
Okay, so that's production. But in post, the editor often has to deal with footage that might be problematic. I can just picture a director wanting their signature sweeping crane shot and the editor realizing it's going to make people feel sick. How do you handle that?
It's tough. You have to explain the concept of the motion intensity bucket. Think of it like filling a bucket with water.
Okay.
The intensity and duration of the camera movement is the water flow. If the flow is too high for too long, the bucket overflows, the viewer hits their discomfort threshold.
So the editor's job is to manage that flow.
Yes. You might need to shorten the duration of the move. You might need to smooth it out, add gentle acceleration and deceleration cues instead of abrupt starts and stops, making it more predictable.
And you mentioned the hardware can actually step in.
Yes, this is critical to convey. visionOS itself monitors for excessive motion. If it detects movement likely to cause discomfort, it can automatically reduce the immersion level, maybe subtly shrinking the field of view or adding stabilization to protect the viewer.
So that epic, intense shot the director wanted might get automatically dampened anyway.
It might, which kind of defeats the purpose of the extreme move in the first place. So it becomes a conversation about finding movement that serves the story without triggering discomfort or system interventions.
Wow. Okay, so we've gone from the nuts and bolts of MVHEVC and that critical ILPD file for AIV through the pipeline and into these really fundamental creative shifts around presence, agency, proximity, and motion.
Yeah, and it all comes back to this core tension, I think. The highest quality experiences, the ones that really push the technology, they often involve this delicate trade-off.
A trade-off between
Maximizing immersion, that feeling of truly being there, using the full capability of the hardware, and maximizing viewer comfort. They aren't always aligned.
Especially with motion.
So
thinking about that and knowing the system itself might step in if you push motion too hard, maybe the final thought for you, the DOP or editor listening, is this. How are you going to approach your camera movements, particularly in post? How will you balance that cinematic ambition to create connection and excitement against the need to keep the viewer comfortable and prevent them from being forced out of that incredible high-fidelity presence you worked so hard to build?
it's the central challenge, I think.
Definitely something to chew on. If you want to start getting hands-on, we really recommend checking out the sample streams available over on developer.apple.com.
And Blackmagic Design also has B-roll footage from the Ursa Cinemmersive available. Great professional source material to experiment with.
Absolutely. Dive in, start playing, and we are really excited to see how you all push the boundaries of this new medium.